continuing with our lab, so we're gonna take and build this PPE device. What we did was we brought it into the Dremel 3D 45 software. Now it doesn't always come in the way you want it, and so basic navigation here. One is you can open files, and you can print more than one. If I want to print two, I can just open a second one. Okay, and then the first one is to move the parts around, so you can move them. It's kind of fun, you know. The idea is how do I maximize this so that when I come in the morning, I have all my stuff made, and that's what's really kind of neat about it. You know, you can come in here like this, and I can take this one, and then I can rotate that. And then I can see how that works, how that looks. I can come back here and move it over. And so you can have an entire assembly of parts printed. And you can have one that's going to be blue, you can have another one that's green, another one that's yellow, and you can run it on 3D printers. And then in the morning, you come back in and everybody puts things together. So number one, being able to set the geometry into the build plate or onto the platen, as I call it. I call it build plate. It's unique. Scaling, you can make them bigger or smaller. So if I wanted to make it 50%, this is for the micro version. And the nice thing about when you make them small is it prints faster. And so we do this quite a bit where it's like, oh, I just need a prototype really quick. And so we'll just scale them down. You click on it and you can go back to 100%. And you can distort them if you uncheck uniform scaling. So you could, like when we do the bases, it's kind of neat to morph them around a little bit. And then orientation is important. So I'm gonna delete this one because we don't need two of them. I'm going to put this one back over into the middle of it. And I'm going to spin it around because I don't know why, but I want it turned this way. Like that. And then what I'm going to do is to click down here. If you want multiple copies of it or mirror images, you can do that. The snap to rotation means it will snap to the table and be flat. This is for creating multiple copies, and so you can make more than one. Oh, sorry, I thought that's what it was. It's not. If I right click on the model and then I say multiply, and I want 4 of them, it'll go through and make 4 of them. When they have these zebra stripes on them, that means there's an error. It's a warning. It's not going to print because it's not orientated in a way that the 3D printer is happy. Undo that. There we go. So we're making this out of PLA, and you can choose these Dremel materials. They have ABS, acrylbutyl sulfate, nylon, PETG, and PLA. PLA is what we use the most. It's reasonably cost about $20 to $30 per roll on Amazon. PETG, you can get some semi-transparent ones. We use those. Nylon, I'm not 100% why. The big thing on nylon, I think it's a little softer. I have to take a look and see what the nylon is. We don't use it very much. And then ABS, which is it's a little harder. A little bit more firm. The problem with PLA is if it's like a vinyl record. If you leave it in your car, it's going to warp. Okay, and so putting stuff outside might not hold up against the elements. We'll go over here to view mode, and we can view the layers. And so if we go to layers, it'll view the layers, and you say, well, it's only got one layer, Joe. What's going on with that? You have to slice it. And so when we bring it in, it comes in just like we did here. And then you hit prepare. And then it will tell you how long it will take to print that. So it's going to say 1 hour and 6 minutes at low quality or 0.3 millimeters per layer. Now, if I want to have something really nice, maybe I've got something that I want to pitch to my marketing team, I want the best quality, I can raise that up and prepare it. And I'm not sure why it's glitching on me here. Right, yeah, there it goes. And the time increases. And so it takes more time, but you get a better build. And then as we look at this, let's go to medium quality. Every time you change anything within the settings, you have to reslice it. There's some window opening somewhere in the background. So we prepare that. And then as we look at it, okay, orientated this way with 59 layers, you can kind of go through and see how it's building it. And as you look at it, this is one of the things that I found about it was it's not solid. When you 3D print things, it prints them like a honeycomb because it doesn't necessarily, it takes a lot of time to print solids and they warp. And so they have something called infill. And so as we start to work with these settings, they have these tweaks. Shell would be the outside layer, this red layer here. Here's my infill and my infill density. So you might be like, oh man, you got to get this printed within an hour. It's 12 minutes over. Oh, well, let's just dial up or dial down the density. So from 30, we'll go to 15, and then we'll re-slice it. Almost. And so now I'm down to 1 hour and 4 minutes, and it's not as fine as it was before. So this part won't be as strong. If I say, let's take it to 10%, and then we prepare it. One hour and 1 minute. All right, let's keep going. Let's go with 8%. Prepare. All right, that doesn't look so good though, right? It's starting to get weak. So we're going to go back to 15%. I think that's what I had it. Only 5%. That looks good. That looks, and you get a feel for it. You can change these infill patterns also. So you can work with some semi-transparent materials and you can change these. I'll go through that in another time, but it's kind of neat. I was doing a chessboard and I was printing the tiles for the chess pieces. And I decided it would look really cool if it was like lit from underneath of the chessboard. And so I printed these tiles with different infill patterns. So you can check how the build looks here. This one has a brim on it. And a brim is a way to adhere it to the top, to the plate. I'm not sure what brim is on here right now. I'll find it. There it is. But it has a raft on it, and that'll hold it to the plate. Another thing is infill. And let's say I took this and I rotated it. And so if I rotate this 90 degrees, and I reslice it. Now I need infill because the printer won't print in the air. I mean, it will, but it won't. It'll sag, and it's something called bridging. And so it'll start off with this raft, and then it builds this up, and it puts the support material in blue, and it's really neat. It's kind of it's kind of fun to actually, it's like bubble wrap, like taking it apart and being able to clean up your models. We recommend having some tools. Having I find the cuticle clippers are really very good for removing material. You can kind of get in there and clip these parts out. but it also increased the build time, see the orientation, and it takes longer. And so when we create these parts, we want to orientate them in a way that prints faster, and if we don't have to use support material, then we get a better build oftentimes. But it depends, as we take a look at these. I'm not sure, why that top looks kind of wonky like that. Somebody may have changed it, maybe me on that. And I'll have to see what's going on with that. On the shell thickness, let's see, top layers. It says it's going to do 4. Let's go with 6. Let's see if it has an effect. We'll come back to that. But you can strengthen your parts as you start to learn how the slicing software works. All right, so we're happy with it. We say, okay, let's go ahead and 3D print this. I'm going to go and see if I can put in my USB. And then I'm going to save this to the removable drive. And so I'll click Save to Removable Drive. And it looks like it put it on my I have so many things open. It put it on my feedback one. And it's called the Deary Door Opener G code. And so if I look at it, so by date, this is the G code for it. And if I open this file, we can use a word processor to look at it, because this is how G codes are written. And so this is what runs a 3D printer. These are remarks when they have a semicolon in them. And then these are G codes that are used to control the print head. And we'll talk about this at a later time, but it's basically X, Y, and Z positions to move the extruder head. And then it has some other aspects of it, as far as to being able to run the cooling fans and other what they call miscellaneous codes. So I have that file, and for some reason, I can't see which one is that. It's because it fell off my desk. There it is. So I'm going to eject that, and then I'm going to put it into one of the 3D printers. And so its name is right here, Deary Door Opener. You can hit the little pencil and change the name if you want to. So I'm going to take this out, and I'm going to bring it over to the 3D printer, and I'm going to put it into the slot there. And then I'm going to hit Build. I'm going to say I want to work from my USB, and then I'm going to find it. And these are folders. It shouldn't be in a folder, I'm hoping. They're listed alphabetically. I'm getting the numbers first, and then I'm just going to double check the name of my file. It's going to be called D3 Deary. It says it's going to take 1 hour and 13 minutes, and then I'll just click on build. It'll copy the files to the 3D printer, and then it will start. The first thing that happens is the head will calibrate the extrusion nozzle to the build plate. And there are these little knobs underneath it, right there in the front, that you can adjust. Sometimes if you're having problems getting a good print, you'll have to go through and level the plate. And what it'll do is it'll take 9 readings to ensure that the plate is flat. And so while it's doing that, I guess we'll just watch. I will pause the recording so that it doesn't. I guess I'll leave it run.
Yeah, I would say in my experience, leveling the build plate is also kind of wonky on the cheaper 3D printers where you have to manually do it. Taking a piece of paper and sliding it under and moving the print head around every corner and making sure that it's there. So one of the first upgrades I bought was a leveling sensor, which wasn't that expensive.
It's an old machine shop technique. The guys will take a piece of paper. If you measure a piece of paper with a micrometer, it's about 0.003 thick. As we're talking, if you guys want to get, if you want to buy stuff, you're looking for an excuse to go shopping, right? Who is it? Get a digital micrometer. And if you go to Amazon and you look at digital micrometers, we really want, we want a digital caliper. And you can get a nice one for about $10. And so I picked up one of these, and it's great because it has, see the blue button there, millimeters and inches. And so a lot of times it's like, hey, this knob broke on my band. Can you make me a new one? It's like, sure. You're trying to measure things. Well, use a caliper. It'll be just perfect. So I recommend, getting one of these. Like I said, it's a good excuse to go shopping, and then you can go run around measuring things. It's a quality issue as well. Did the parts print to the correct size? And you can verify it. So every month I have the lab assistant go through and calibrate the 3D printers. And to do that, he prints a test cube for me. And so the test cube then has a specific size to it, and we can go through and check on it. So that's a good thing to have. And then, as you can see, what's going on with the printer right now is it's heating the build plate, and then it's heating the nozzle. And when it comes up to temperature, then it will start printing. All right. So there it goes. They do have cameras inside the printers as well, but I do not have that component set up in my office.
Did something disconnect there on the left?
Can you say that again?
It looks like some tube is disconnected from the printhead there on the left. That white thing hanging down. My left. I don't know if that's your right or left.
No, you're right. So it broke the filament.
Oh, is that the filament itself? Yeah, it's hard to tell.
It is, and thanks to your assistance on it, we can pause it. I'm going to stop it. We'll say yes. And this is typical of what happens.
Yes.
It's an error, okay? And it happens, when you out of the office due to the pandemic. And so we have this piece. So we'll fix it. By going to filament and change filament. It'll preheat it up to 230. And then what we do is we take the filament It's probably a better idea if I would have taken a fresh one out of the box because they're sealed in plastic.
Mhm.
And it's just like I guess, you know, if you compare it to food, it's best when it's fresh. So once this gets up to 230, what I'll do, and this is a little wonky, the way they set it up, you put this into this infeed tube, and then there's a little button that we push right here that gets it in between the head, and there's two gears, and I kind of give it a push,
Mhm.
make sure that it's getting it. You don't want to push real hard, just a light touch, because they are sensitive machines.
And you want to be careful about what you touch because things are hot in there. The printhead and the bed.
Yeah, I recommend that you get a pair of tweezers.
Mhm.
And so we'll have tweezers, and a little flashlight is nice to have too. It'll detect with the RFID sensor the material, so I'll accept it. And then I'll go back in and print it again. So I'll say build USB, find by part. And then it'll go through the startup applications for that. I can see that we're at 10 o'clock, and what I'll do is I'll go for a little bit longer, and I'll stop the recording, and then I'll just leave the meeting open. I have plenty of time to go through and work with this. I just don't want to have everybody think that they have to stay if they have other things to do. Typically, Al and I will run the meetings for an hour. And so we'll go from 9 to 10 or 10:30. It's only a 2 credit hour course, so I think we're within our lecturing, how much we're supposed to lecture. If I turn off the screen sharing, I think. Not sure how to do that. Probably make the presentation bigger. There it is. Let's see if we can get that. There we go. Nice and big, right, guys? And so you can see it's going through and it's calibrating. And it's going to be pretty quick now because it should be heated pretty close to the temperature of the correct temperature for the extruder and for the build torque. And so down here on the bottom, there's these little dial indicators that tell you how much it's in. So if we look at it down here, I'm at about 3/4 on the nozzle, and the platform is at 100%. It's at 35 degrees Celsius, and that one's at 220. And if you want to convert that, probably around 400 degrees. So we're looking at Google is so much better. I don't know why. It's Yahoo stuff. Yeah, 428 degrees. And we can see that it's starting to build. I'll see if I can. The first layer height is very important, or at least the first layer. And then it'll give me my build time. And so if I read it, it's going to say 1 hour and 13 minutes. You can pause, you can stop, you can change the filament to a different color. That's sort of a trick that we'll use. And that's basically it. That's how you would get the print started. With that, I'm going to stop the recording, and then in 1 hour and 13 minutes, we'll have some PPE door openers. All righty, so let's see my recording controls here. Let's go back to my share screen. Okay, so this ends the recording of how to print the second part of lab.